Hey everyone! So picture this, you wake up and your coffee is already brewing, perfectly to your taste. Your personalized virtual assistant has already optimized your schedule for the day, factoring in traffic, your meetings, and even your mood. Later, a routine checkup doesn't involve a sterile clinic. Instead, your doctor is monitoring your neural activity remotely, making sure your brain health is in top shape, maybe even suggesting a cognitive boost based on your brainwave patterns. Sounds like a scene ripped straight from a high-budget sci-fi movie, right? Well, what if I told you this isn't some far-off distant dream, but a rapidly approaching reality? The seeds of this future are being sown right now, with breakthroughs happening at an astonishing pace. The next 10 years are poised to unleash a wave of technological advancements that will fundamentally reshape our daily lives, our industries, and even our understanding of what it means to be human. These aren't just incremental updates to the tech we already use, we're talking about paradigm shifts, new categories of tools and experiences that will feel as transformative as the internet or the smartphone did in their time. It's a future where intelligence is embedded in everything, where the digital and physical worlds merge seamlessly, and where human potential is augmented in ways we're only just beginning to imagine. These are the top 10 technology trends that will define the next decade. Welcome back to SpeciFact. If you're new here, we dive deep into the technologies and scientific breakthroughs shaping our world. Make sure you hit that subscribe button and ring the bell so you don't miss out on our future explorations. We've got a lot to cover, and trust me, you're going to want to stick around for this one. Alright, let's jump into the top 10 technology trends that are set to change our world forever. Alright, kicking things off at number 1, we have Agentic AI. Now, we've all gotten used to chatbots and virtual assistants like Siri or Alexa. They can answer questions, set timers, play music, pretty useful but still fairly limited in scope. They mostly react to our commands. Agentic AI, however, is a whole different ballgame. We're talking about AI systems that are evolving beyond simple response mechanisms into proactive, autonomous agents capable of making decisions and executing complex tasks with minimal human intervention. Think of them less as tools and more as digital colleagues or partners. These intelligent agents are being designed to understand context, learn from interactions, and pursue goals independently. Instead of just fetching information, an agentic AI might manage your entire travel itinerary, from finding the best flights and accommodations based on your preferences and past behavior, to automatically rescheduling if there's a delay, and even negotiating for a better room or a refund. It's about giving AI the agency to act on your behalf, to truly take initiative in a way that current AI simply can't. This means a shift from programming specific instructions to defining broader objectives and letting the AI figure out the best way to achieve them. The core idea here is to reduce the cognitive load on humans. Imagine an AI agent that can manage your small business's social media, not just by scheduling posts, but by analyzing engagement, identifying trending topics, creating draft content, and responding to customer inquiries in a nuanced way. Or an agent in a scientific research setting that can design experiments, analyze data, and even propose new hypotheses. This level of autonomy requires sophisticated reasoning, planning, and problem-solving capabilities that are at the forefront of AI research today. The line between human intelligence and machine intelligence will start to blur in fascinating and perhaps slightly unsettling ways. These agents won't just be processing data, they'll be interpreting it, making judgments, and taking actions in the real world or the digital world with significant consequences. This means they'll need to understand not just the what, but the why behind tasks, and even anticipate needs before they're explicitly stated. It's a move towards AI that doesn't just assist, but collaborates and even leads. Of course, this brings up a whole host of questions around trust, accountability, and control. If an AI agent makes a mistake, who's responsible? How do we ensure these agents align with human values and ethical principles? These are not trivial challenges, and they'll need to be addressed thoughtfully as agentic AI becomes more integrated into our lives. The potential for increased efficiency and innovation is immense, but so is the need for careful oversight and robust safety protocols. Ultimately, the rise of autonomous agents promises a future where technology takes on more of the complex, time-consuming tasks, freeing up human intellect and creativity for higher-level thinking and more meaningful pursuits. It's about creating a partnership where AI handles the operational complexities, allowing us to focus on strategic goals and innovation. This isn't just about smarter software, It's about a fundamental shift in how we interact with and leverage artificial intelligence across every sector. Next up at number 2 is a technology that sounds like it's straight out of science fiction, but is rapidly becoming a reality: quantum computing. Our current computers, the ones in our phones, laptops, and even supercomputers, operate on bits, which can be either a 0 or a 1. It's a binary system that has served us incredibly well. Quantum computers, however, use qubits. Thanks to the principles of quantum mechanics like superposition and entanglement, a qubit can be a 0, a 1, or both, simultaneously. This seemingly small difference unlocks an exponential increase in processing power for certain types of problems. Think about problems that are currently intractable for even the most powerful classical supercomputers. Things like discovering new drugs and materials by simulating molecular interactions at an incredibly precise level, or optimizing complex logistical systems with millions of variables like global supply chains or financial modeling. These are tasks where the number of possibilities is so vast that a classical computer would take billions of years to crunch through them. Quantum computers, with their ability to explore many possibilities at once, promise to solve these kinds of problems in a matter of hours or days. This isn't just about doing things faster, it's about doing things that were previously thought impossible. In medicine, quantum computers could revolutionize drug discovery by accurately modeling how different molecules interact with proteins in the human body, leading to highly effective, personalized treatments. In material science, they could help design new catalysts for cleaner energy production or super-efficient batteries. The potential impact spans across finance for optimizing investment portfolios and risk assessment, to climate change research by creating far more accurate climate models. One of the most talked about implications of quantum computing is its ability to break current encryption methods. Most of the encryption that protects our sensitive data online, from bank transactions to private messages, relies on mathematical problems that are too difficult for classical computers to solve in a reasonable time frame. Quantum computers, however, are theoretically capable of cracking these codes with relative ease. This is a huge deal, and it's driving a race to develop new quantum-resistant encryption algorithms to safeguard our digital infrastructure for the future. Now it's important to manage expectations. We're still in the early days of quantum computing. Building and maintaining stable, large-scale quantum computers is an immense engineering challenge. They are sensitive, require extreme conditions like near absolute zero temperatures, and are prone to errors or noise. But the progress being made by companies like Google, IBM, and numerous startups is incredibly rapid. We're seeing increasingly powerful and stable quantum processors being developed, and researchers are constantly finding new algorithms and applications. So, while you probably won't have a quantum computer on your desk by 2030, the impact of this technology will start to be felt through cloud-based quantum computing services. Businesses and research institutions will be able to tap into this power to solve specific, complex problems, leading to breakthroughs that will ripple through various industries. It's a foundational shift in computation, and the next decade will be crucial in unlocking its transformative potential. Coming in at number 3 is a trend that might not sound as flashy as AI or quantum, but is absolutely critical for the sustainable future of technology, energy-efficient and nuclear-powered computing. As our reliance on digital infrastructure grows, so does its energy footprint. Data centers, the backbone of the internet, cloud computing, and AI, are already consuming a significant percentage of global electricity, and that demand is projected to skyrocket. This isn't sustainable with our current energy sources and computing architectures. The push for sustainable computing is multifaceted. Firstly, there's a huge focus on developing smarter algorithms, particularly AI-driven ones, that can optimize energy usage within data centers. This means dynamically allocating resources, predicting workloads to power down idle servers, and managing cooling systems more efficiently. Even small percentage gains in efficiency can translate to massive energy savings when scaled across the thousands of data centers worldwide. It's about making the software itself less power-hungry. Secondly, there's a continuous drive for more energy-efficient hardware. This includes new chip designs that deliver more processing power per watt, advancements in cooling technologies, like liquid cooling instead of traditional air conditioning, and even rethinking the physical layout of data centers to minimize energy loss. Companies are investing heavily in research and development to create processors and memory that sip power rather than guzzle it, without sacrificing performance. This is crucial for everything from massive server farms to the tiny chips in our IoT devices. But here's where it gets really interesting. The exploration of nuclear power, specifically small modular reactors or SMRs, to provide dedicated, clean and reliable energy for large-scale digital infrastructure. SMRs are designed to be much smaller, safer and more flexible than traditional nuclear power plants. The idea is that a data center or a campus of data centers could have its own SMR, providing a consistent and carbon-free power source, independent of the grid's fluctuations or reliance on fossil fuels. This is a pretty bold step, but some major tech players are seriously considering it. The appeal of nuclear power for data centers lies in its energy density and reliability. Unlike solar or wind, nuclear can provide baseload power 24/7, which is exactly what data centers need. While there are obvious concerns around safety, waste disposal, and public perception, the new generation of SMR designs aims to address many of these issues. The debate is ongoing, but the fact that it's being seriously discussed highlights the urgency of finding powerful, sustainable energy solutions for our digital world. Ultimately, the goal is to move towards a future of green computing where our digital lives don't come at such a high environmental cost. This involves a combination of renewable energy sources, highly efficient hardware and software, innovative power solutions like SMRs, and a circular economy approach to electronics. By 2030, we expect to see significant strides in making our digital infrastructure not just more powerful, but also much, much greener. It's a necessary evolution for a tech-dependent world. At number 4, we're looking at a fundamental shift in where and how data is processed. Hybrid and edge computing. For years, the trend was to centralize data processing in massive cloud data centers. And, the cloud is great for many things: scalability, storage, and running complex analytics. But it's not always the best solution, especially when you need super fast response times, or when you're dealing with massive amounts of data generated far from those central hubs. That's where edge computing comes in. Edge computing is all about processing data closer to where it's generated, at the edge of the network. This could be on a factory floor, inside an autonomous vehicle, in a smart city sensor, or even on your local device. By processing data locally, you significantly reduce latency, that annoying lag or delay. For applications like self-driving cars, industrial robotics, or real-time patient monitoring in healthcare, minimizing latency isn't just a convenience, it's critical for safety and functionality. Then there's hybrid computing, which, as the name suggests, combines the best of different worlds: public cloud services like AWS or Azure, private cloud infrastructure, and edge computing resources. It's not an either-or situation. Instead, organizations can choose to process and store data where it makes the most sense for that specific workload, balancing cost, performance, security, and compliance requirements. Some data might need the massive scale of the public cloud, while sensitive data or latency-critical applications run on-premise or at the edge. This distributed approach offers several key advantages. Beyond reduced lag, edge computing can also save on bandwidth costs, as you're not constantly sending huge volumes of raw data back and forth to a central cloud. It can also improve reliability, as applications can continue to function even if the connection to the central cloud is temporarily lost. And for certain industries or regions, keeping data localized due to privacy regulations or data sovereignty laws is a major driver for adopting edge and hybrid models. Consider a smart factory. Sensors on machinery generate vast amounts of data. Sending all that data to the cloud for analysis would be slow and expensive. With edge computing, initial processing and anomaly detection can happen right on the factory floor, enabling immediate alerts or adjustments to machinery. Only summarized data or critical insights might then be sent to the cloud for longer-term analysis or integration with other business systems. This makes operations more efficient and responsive. By the year 2030, we'll see a much more intelligent and distributed computing landscape. The cloud won't just be a few giant data centers, it will be a continuum of computing resources from the central core to the far edge. Applications will be designed to leverage this distributed architecture, dynamically shifting workloads to the optimal location. This shift is essential for enabling the next generation of real-time, data-intensive applications that will define our connected future, from autonomous systems to immersive AR and VR experiences. Sliding into our number 5 spot is 5G expansion. Now I know what some of you might be thinking: 5G is already here, right? And yes, many of us have 5G phones and are seeing faster download speeds. But what we've experienced so far is largely just the tip of the iceberg. The true potential of 5G, especially its ultra-low latency and massive connectivity capabilities, is still unfolding, and by 2030, it will be the undisputed backbone of our increasingly connected world, enabling applications we can barely imagine today. It's crucial to understand that 5G isn't just about making your Netflix stream smoother. Its design pillars include enhanced mobile broadband. So, faster speeds, yes, but also massive machine-type communication, or MMTC, and ultra-reliable low-latency communication, or URLLC. MMTC allows for connecting a huge density of devices. Think billions of IoT sensors in a smart city or industrial setting. URLLC, on the other hand, provides incredibly quick and reliable data transmission, which is essential for mission-critical applications. This combination will power truly smart cities. Imagine traffic lights that dynamically adjust to real-time traffic flow, public transportation that's perfectly synchronized, and city infrastructure that can predict and report maintenance needs automatically. Emergency services could benefit from real-time video feeds from drones or body cams, and enhanced situational awareness, all thanks to the high bandwidth and low latency of a mature 5G network. This isn't just about convenience. It's about efficiency, safety, and sustainability. Autonomous vehicles are another prime example. For self-driving cars to operate safely and efficiently, they need to communicate with each other, that's vehicle to vehicle, or V2V, with infrastructure like traffic lights, which is vehicle to infrastructure, or V2I, and with pedestrians, known as vehicle to pedestrian, or V2P. Collectively, this is called V2X communication. This requires a network that can handle vast amounts of data with near zero delay. 5G is designed for exactly this, enabling a level of coordination and awareness that's impossible with current network technologies, making roads safer and traffic flow smoother. And then, there's the impact on immersive experiences like augmented reality and virtual reality. Current AR and VR can often feel tethered or require significant local processing power. A robust 5G network can offload much of this processing to the edge cloud, allowing for lighter, more comfortable headsets and truly untethered, high-fidelity experiences. Think collaborative design in VR, remote expert assistance via AR, or immersive entertainment and gaming, all streamed seamlessly over 5G. By 2030, 5G deployment will be far more widespread and mature, including the rollout of standalone 5G networks that don't rely on older 4G infrastructure. This will unlock its full capabilities, leading to a proliferation of new services and business models. From remote surgery and precision agriculture to fully connected logistics and manufacturing, 5G will be the invisible force enabling a smarter, faster, and more interconnected world. It's the foundational layer upon which many other tech trends on this list will be built. At number 6, we have spatial computing, which is all about blurring the lines between our physical world and the digital realm. This isn't just one technology, it's more of a convergence of several augmented reality, virtual reality, and mixed reality together. They're creating entirely new ways for us to interact with information with each other and with our surroundings. By 2030, spatial computing will have moved far beyond niche gaming applications and become a mainstream interface. Let's quickly break them down. Virtual reality, or VR, completely immerses you in a digital environment, shutting out the physical world. Think of putting on a headset and being transported to a different planet or a historical event. Augmented reality, or AR, overlays digital information onto your view of the real world. This could be navigation arrows appearing on the street through your smart glasses, or product information popping up when you look at an item in a store. Mixed reality, or MR, takes this a step further by allowing digital objects to interact with the real world in a more integrated and seemingly tangible way. Imagine a virtual three-dimensional model of a new engine sitting on your physical workbench, which you can walk around, inspect, and even disassemble with hand gestures. MStar anchors digital content to your physical space, making it feel more present and interactive. This is where spatial computing gets really powerful. The applications for this are incredibly broad. In training and education, spatial computing can provide highly realistic and safe simulations for complex tasks. Think surgeons practicing a new procedure in MR, or engineers learning to repair intricate machinery in VR. In retail, you could visualize how furniture would look in your living room using AR, or virtually try on clothes. For collaboration, teams spread across the globe could meet in a shared virtual space, interacting with three-dimensional models and data as if they were in the same room. The user interface itself is evolving. Instead of just screens and keyboards, we'll be interacting with digital information using gestures, voice commands, and even eye tracking. The computer becomes less of a distinct object and more of an integrated layer within our environment. This requires sophisticated sensors, powerful local processing, and intuitive software that can understand and map the user's surroundings in real time. By 2030, expect to see lighter, more comfortable, and more powerful AR and MSTR glasses becoming commonplace, perhaps even starting to replace smartphones for certain interactions. The development of spatial computing platforms will empower creators to build a new generation of immersive experiences that will transform how we learn, workshop, and play. It's about making our interaction with technology more natural, intuitive, and deeply integrated with the world around us. Coming in at number 7 is a significant evolution in robotics: polyfunctional robots. For a long time, robots, especially in industrial settings, have been highly specialized. You have a robot arm that does one thing, like welding a specific part or painting a car panel, over and over again with high precision. These are incredibly effective for mass production, but they lack versatility. Polyfunctional robots, as the name implies, are designed to be adaptable and capable of performing a wide range of tasks, much like a human worker. This shift is being driven by advancements in artificial intelligence, machine vision, sensor technology, and more dexterous manipulators. Instead of being rigidly programmed for a single repetitive motion, these new robots can perceive their environment, understand complex instructions, learn from new situations, and switch between different tasks dynamically. Think of a robot in a warehouse that can not only pick and pack items of various shapes and sizes, but also help with inventory management, clean the aisles, or even assist with simple maintenance tasks. This versatility will transform workplaces far beyond the factory floor. In healthcare, polyfunctional robots could assist nurses with patient mobility, deliver supplies, take vital signs, or disinfect rooms, freeing up human staff for more critical patient care. In agriculture, they could handle everything from planting and weeding to harvesting different types of crops, adapting to changing conditions in the field. Even in construction, robots capable of bricklaying, welding, and site inspection could improve safety and efficiency. The home is another area where these multi-talented robots will make a significant impact. We're moving beyond simple robot vacuums to more sophisticated domestic assistants that could potentially help with cooking, laundry, tidying up, or providing companionship and assistance for the elderly or those with disabilities. For this to happen, robots need to be safe to operate around humans, easy to interact with, and capable of navigating complex, unpredictable home environments. Developing these capabilities is, honestly, a huge engineering and AI challenge. Robots need to understand natural language, interpret subtle human cues, manipulate objects with human-like dexterity, and make sensible decisions in novel situations. The brains of these robots will rely heavily on machine learning, allowing them to improve their performance over time through experience and data. This also means robust safety protocols are paramount, ensuring these robots can operate autonomously without posing a risk. By 2030, we'll see polyfunctional robots becoming increasingly common in various industries and potentially starting to make their way into our homes. They won't necessarily replace human workers entirely, but will augment human capabilities, taking over dangerous, dull, or physically demanding tasks. This will lead to a rethinking of job roles and the skills required in the workforce, emphasizing human strengths like creativity, critical thinking, and complex problem-solving in collaboration with these intelligent machines. At number 8, we delve into a truly mind-bending area: neurological enhancement. This field encompasses technologies designed to interact directly with the human brain and nervous system, primarily to read brain activity, but increasingly with the potential to enhance cognitive functions or restore lost capabilities. While still in its relatively early stages, the progress here is accelerating, and by 2030, we could see some remarkable applications alongside profound ethical discussions. Currently, much of the focus is on brain-computer interfaces, or BCIs. These can be non-invasive, like EEG headsets that read electrical activity from the scalp, or invasive, involving surgically implanted electrodes that can record or stimulate neural activity with much higher precision. Early applications have been revolutionary for individuals with severe paralysis, allowing them to control prosthetic limbs, communicate via text, or even operate computers using only their thoughts. This restorative aspect of neurological tech is undeniably life-changing. Beyond restoration, however, lies the realm of enhancement. Researchers are exploring how BCIs and other neurostimulation techniques might be used to boost cognitive abilities such as memory focus, learning speed, or even creativity. Imagine students being able to absorb information more effectively, or professionals maintaining peak concentration for longer periods. This is still largely experimental, but the theoretical possibilities are compelling. Of course, the idea of directly interfacing with and potentially modifying brain function raises significant ethical, social, and security challenges. The privacy of our thoughts is a fundamental concern. If our brain activity can be read, who has access to that data, and how is it protected? Could this lead to new forms of surveillance or manipulation? Then there's the issue of cognitive inequality. If enhancement technologies are expensive, could they create a divide between the neurologically enhanced and unenhanced? Security is another major hurdle. If our brains are connected to external devices or networks, they could theoretically be vulnerable to hacking. The prospect of brainjacking, while sounding like science fiction, is something researchers and ethicists are taking seriously as these technologies develop. Ensuring the safety, security, and ethical use of neurological enhancements will be paramount and will require robust regulatory frameworks and public discourse. Despite these challenges, the potential benefits, particularly in medicine, are enormous. Beyond paralysis, neurological tech could offer new treatments for conditions like epilepsy, Parkinson's disease, depression, and Alzheimer's. By 2030, we'll likely see more sophisticated diagnostic tools based on brain activity analysis and more refined therapeutic interventions. The line between therapy and enhancement will continue to be debated, but the drive to understand and interact with the brain, the most complex object in the known universe, will undoubtedly lead to incredible breakthroughs. Number 9 on our list is a technology that many still primarily associate with cryptocurrencies like Bitcoin, but its potential goes far, far beyond blockchain. At its core, a blockchain is a distributed, immutable ledger. That means it's a shared database, copied across many computers where transactions or records, once added, cannot be altered or deleted. This inherent transparency and security are what make it so powerful for building trust in digital interactions without necessarily needing a central authority. While crypto was the first major application, by 2030, we'll see blockchain technology underpinning a wide array of systems where trust, transparency, and data integrity are crucial. One of the most promising areas is supply chain management. Imagine being able to track a product, say a piece of fruit or a pharmaceutical drug, from its origin all the way to the consumer, with every step recorded on an immutable blockchain. This can help verify authenticity, combat counterfeiting, ensure ethical sourcing, and improve food safety. Medical records are another key application. Currently, patient data is often siloed in different hospital systems, making it difficult to share and access when needed. A blockchain-based system could give patients more control over their own health information, allowing them to grant secure, auditable access to different healthcare providers as needed. This could improve diagnostic accuracy, streamline care, and enhance patient privacy, ensuring that the record is complete and untampered with. The beauty of blockchain lies in its ability to facilitate trust between parties who may not know or inherently trust each other. By creating a shared, verifiable record of transactions or information, it reduces the need for intermediaries, which can lower costs and increase efficiency. This is applicable to areas like intellectual property rights management, real estate transactions, academic credentialing, and even managing digital identities in a more secure and user-centric way. Of course, blockchain isn't a silver bullet. There are challenges related to scalability, energy consumption, and the complexity of implementation. However, newer generations of blockchain technology are addressing these issues with more efficient consensus mechanisms and improved scalability solutions. By 2030, expect to see mature, enterprise-grade blockchain platforms becoming integral to how we manage and verify information in a decentralized world, quietly building trust into the fabric of our digital interactions. And finally, at number 10, we have a trend that aims to make technology so seamless it almost disappears: ambient and invisible intelligence. This is the idea that computing power and connectivity will be woven into the fabric of our environment, our homes, our offices, our cities, working proactively and intuitively in the background, without requiring our constant attention or explicit commands. Think of it as technology that anticipates our needs and automates tasks so smoothly that we barely notice it's there. We're already seeing early glimpses of this with smart home devices, lights that turn on when you enter a room, thermostats that learn your preferences and adjust automatically, voice assistants that can control multiple devices. Ambient intelligence takes this much further. Imagine your environment intelligently adapting to you, your office adjusting lighting and temperature based on your biometric data for optimal focus, or your kitchen suggesting recipes based on the ingredients you have and your dietary goals, perhaps even preheating the oven. This requires a sophisticated interplay of sensors, AI, and interconnected devices, the Internet of Things, or IoT. These systems will constantly gather data about our environment and our behavior ethically, and with our consent, of course, to learn our patterns, preferences, and needs. The AI then acts on this understanding to provide assistance, automate routines, or deliver relevant information at just the right moment, often without us even having to ask. The goal is to reduce friction and cognitive load. Instead of juggling multiple apps and devices, the intelligence is embedded and context-aware. For example, as you leave work, your smart car might already know your preferred route home based on real-time traffic. Your home environment might start adjusting to your arrival temperature, and your evening playlist might be queued up. It's about creating a more fluid and intuitive interaction with technology, where it serves us almost invisibly. This also extends to public spaces. Smart cities with ambient intelligence could optimize traffic flow, manage energy consumption more efficiently, enhance public safety through intelligent surveillance with appropriate privacy safeguards, and provide citizens with real-time, personalized information about public transport or local events. The environment itself becomes an active participant in making life smoother and more efficient. Of course, for ambient intelligence to be truly effective and accepted, issues of privacy, security, and user control are paramount. Users will need to have clear understanding and control over what data is being collected and how it's being used. But the allure of technology that simplifies our lives by fading into the background is strong. By 2030, we'll be living in environments that are much more responsive and attuned to our needs, with technology working silently to make our daily routines more effortless and our interactions with the world more seamless. So, those are the top 10 technology trends that will define our future, or at least a very significant part of it, as we head towards 2030. From agentic AI becoming our proactive digital partners and quantum computers solving currently impossible problems, to the seamless integration of ambient intelligence into our daily lives, the next decade promises a truly transformative journey. These aren't just isolated advancements. They're interconnected, often building upon each other to create an entirely new technological landscape. It's a future that's coming fast, and it's incredibly exciting. These trends are fundamentally reshaping how we live, how we work, how we connect with each other, and even how we understand ourselves. The world of 2030 will likely feel quite different from the world of today, in ways both big and small. As with any major technological shift, there will be incredible opportunities but also new challenges to navigate, particularly around ethics, privacy, and societal impact. Staying informed and engaged with these developments isn't just for tech enthusiasts. It's becoming essential for everyone to thrive in this rapidly changing world. The pace of innovation is relentless, and it's a pretty wild ride. But that's what makes exploring these frontiers so compelling. We're genuinely curious to hear your take. Which of these trends excites you the most? Or perhaps which one gives you the most pause? Drop your thoughts in the comments below. Let's get a conversation going. Thanks for watching, and if you enjoyed this deep dive, make sure to like, subscribe, and hit that bell for more explorations into the future.